Hello everyone, my name is Javier de la Rosa and I am a postdoctoral researcher at the PostData project for poetry standardization and linked open data. Today I'm going to be talking about predicting metrical patterns in Spanish poetry using language models. The process of extraction of metrical patterns in poetry, also called scansion, is tightly related to the syllabification and assignment of stress. After you syllabify the words into the component syllables, you can assign a stress. For each unstressed syllable, a hyphen is usually assigned, and for each stressed syllable, a plus symbol is assigned. This sequence of hyphen and plus symbols are what we call the metrical pattern of the word. By composing all the individual metrical patterns of each word, we can extract the metrical pattern of a line of verse in a poem. For example, here we can see what the metrical pattern for a real, actual verse will look like. The verse in question is by Garcilaso de la Vega and is Cubra de nieve la hermosa cumbres. The metrical length of this metrical pattern would be 11, since there are 11 metrical syllables involved. However, this process is not always straightforward. For example, some words, even though they should be assigned a specific sequence of pluses and hyphens, they are not because of the function in the sentence. For example, adverbs are usually not assigned the corresponding stress syllable with a plus symbol. This is important because depending on where the last stress syllable is in the last word of a verse, we have to add, subtract, or leave the metrical pattern intact. For oxytone words, we add a new hyphen to the metrical pattern. For paroxytone words, we leave it as they are. And for paroxytone words, we need to subtract one of the hyphens. This is shrinking or expanding on the metrical pattern is not always straightforward. There are other rhetorical devices that poets use to shrink or expand their metrical patterns. One of them is synalepha, in which two syllables pertaining to different words are joined together in pronunciation, making for one only single metrical syllable. A similar process is syneresis, in which two syllables within the same word are joined together and represented only with one symbol in the metrical pattern. Conversely, the rhetorical figure called diaresis is the splitting of a naturally occurring diphthong into two or more different syllables. Usually, rule-based scansion processes or rule-based metrical pattern extraction systems have 4 steps. The first one is the assignment of part of speech tags. There is a second step in which we apply syllabification. After that, stress and identification of each individual phonological unit is run. Finally, some sort of post-processing for adjustment of the metrical pattern and length. We fine-tune different pre-trained language models, mostly BERT-based models, adding a linear layer and a dense layer using 11 dimensions if for one syllable of our corpus, because the corpus we use to test the system was only composed of endecasyllables, and then we compare our approaches with the current state-of-the-art in role-based systems. We found that we were not able to outperform the current state-of-the-art, but we did outperform all previous rule-based models. So we believe that by making this comparison, we have proven that BERT-based models actually retain enough structural and even prosodic information to perform well in these kind of tasks. Our results can be proved by adding estimate layers, maybe even GLU units, and of course further in domain training. Moreover, we want to analyze the performance of these BERT-based models on other poetry tracks that are really readily available. Thank you so much. I'm ready for your questions.